Hi there, Mr. Sutton here, bringing you the AB Calculus 4-3 classwork extra practice solutions on local extrema. For this problem, we have to read very carefully. They want to know at what x value the derivative of this f of x function attains a maximum value. So we're basically trying to figure out where f prime is maximized, not f. Well, if I want to know how I can maximize f prime, I need f double prime. So I need two derivatives here. So for the first one, using our power rule, this is going to be 4/3 x to the third minus 5's cancel, so this is just x to the fourth. And then let me find f double prime now. 3's cancel, that's going to be 4x to the second minus 4x cubed. Now I just need critical values for this. So I can take out an x squared. That leaves actually a 4x squared, so that's going to be 1 minus x left inside, and I'm just setting this thing equal to 0 and solving now. So 1 minus x then. And this is going to equal 0 at x equals 0 and positive 1. So let me make my number line. This is an f double prime number line. We've got 0 and 1. And let me test something to the left of 0, like negative 1. Now, plugging it back in this f double prime here, this 4x squared is always going to be positive, so it's really just the 1 minus x that determines the sign. 1 minus negative 1 is going to be a positive. Now let's test something between 0 and 1, like 1/2. 1 minus a half is still positive. And then something to the right of 1, like 2. 1 minus 2 is negative. Now I see that f double prime is changing from positive to negative at x equals 1. And actually, they wanted us to do a little bit more here. They wanted the maximum value, just the overall maximum value. So my local max is going to be an absolute max in this case. So the way I'm going to show this, f double prime is greater than 0 for x less than 1. So f prime is then increasing until we get to 1. And f double prime is less than 0 after 1. Well, this being the case, if f prime is increasing until we get to 1 and decreasing after, that means f prime must reach its maximum value at x equals 1. So that's going to be choice C. On this problem, we want to know at what x values this function has a relative max. So we need to know where f prime is changing from positive to negative for this thing. Let's start by finding f prime. Now there's a few ways to do this. One of them is to expand all of this out, get a polynomial, and use the power rule. Another way is to use the product rule. I think at the end, half a dozen of one, 6 of the other. I'm just going to use product rule. So let me do, we've got x minus 2 and x minus 3 squared. The derivatives of those are pretty easy. We've got just 1, and this one is just going to be 2 parentheses x minus 3, or 2x minus 6, either way. So now putting it all together with the ribbon, I've got 1 times x minus 3 squared, plus we have a 2, an x minus 2, and x minus 3, all of that together there. And I want to figure out where this thing equals 0, solving for critical values. So I notice here that I can factor out an x minus 3. If I do that, what I've got left is, well, another x minus 3, and also I have a plus some other stuff, plus 2 parentheses x minus 2. So far so good. I'm almost at a place where I can start solving for x, but let me clean up this brackety parentheses a little bit. So if I distribute this 2, we've got a 2x, plus this x gives us a 3x in there. And then, let's see, I've got a negative 2 if I distribute this, or negative 4 rather, if I distribute this 2. Negative 3 plus this negative 4 over here is going to be minus 7. So this is going to equal 0 at x equals 3. And for this one, if I add 7, divide by 3, that's going to be 7/3. Let me put this on a number line now. So this is f prime that I'm finding a sign chart for. And I've got, let's see, 7/3 is smaller, so 7/3 is the first thing, followed by 3. Let me test something to the left of 7/3, like 0 is an easy one. And I'm using this last simplified version of everything now for f prime. So I've got essentially negative 3 and negative 7. That's going to come out positive. Testing something between 7/3 and 3. Not a whole lot of things in between there. I mean, granted, there's an infinite number of things, but not a whole lot of easy things. I'm going to go with 8/3 because 3 is really 9/3. So using 8/3, that's going to be a little bit less than 3, so subtracting 3 makes that negative for that first thing. 3 times 8/3 is 8, minus 7 is a positive. Negative times a positive is negative. And this last one's a bit easier. I'll just use 4. So that's going to come out positive and positive, so positive overall. And I see here that we're changing from positive to negative at x equals 7/3 for f prime there. So that means f is going to have a relative max at x equals 7/3. Choice D. For this problem, we want to know where this f function has a relative min at what x value. Now the answer choices on this are a little bit wild. I mean, D and E, it looks like there's some quadratic formula going on. Let's hope we don't have to go down that road. To find the relative min, I need to know where f prime changes from negative to positive. So f prime is going to be, let's see, 6x squared minus 6x, just using our power rule here, minus 12. And we want to know where that equals 0 for critical values. I can factor out a 6 from all this. That'll be x squared minus x minus 2. And that's pretty easy to factor. Things that multiply to negative 2 and add up to negative 1, that would be positive 1 and negative 2. So we see then that f prime equals 0 at x equals negative 1 and positive 2. And that's something we can put on a sign chart and do a little analysis. So here's my f prime sign chart. We've got negative 1, positive 2 for those values. Something to the left of negative 1 I'll test out, like negative 2. So that's going to be a negative times a negative, comes out positive. Between negative 1 and 2, I'm going to test out 0. That's a positive and a negative, so negative overall. And something bigger than 2, like 3, that's positive, positive, comes out positive. We wanted a relative min. I see that f prime changes from negative to positive at x equals 2. So that means f has a relative min at x equals 2, which is choice C. On this problem, I'm given the derivative of some function, f prime here. We want to know where the original function, f, at what x value, this has a relative max. If I'm looking for relative max for f, I'm really looking for places where f prime is changing from positive to negative. And this is a graphing problem, so I'm just actually going to graph out this function they gave me and see where we cross the x-axis in that fashion. So f prime changes positive to negative where? Let's find out. So here I am in the calculator. I've entered f prime in my y1, and I need a window. Now, they didn't actually give us a good window on this one, but if you look at the answer choices, let's see, they're between, let's say, negative 1 and positive 4 is as big as this could possibly be. So let me go to my calculator, and for window, I'll go from negative 1 to positive 4. And then let me zoom fit this thing. See what we end up with. So there is my f prime. And I see that I'm going from, let's see, I wanted a relative max. So I'm going from positive to negative at only one spot, this spot right here. Let me do second trace option 2 and figure out where that is. Let me arrow over here, get my spider a little bit to the left, press enter, a little bit to the right, press enter a third time for kicks and giggles, and then we have about 0.910 where we intersect there. So since f prime changes positive to negative at 0.910, that means f has a relative max there. So that would be choice C. On this problem, I want to know the minimum value of f of x equals x ln of x. So this is a little bit wild because they're basically asking for the absolute min for something that they did not give us a closed interval on. So we're going to have to do this finding local mins and hoping we can actually show that they're absolute mins. Let's start by taking a derivative. So we're going to need the box and ribbon for this, the product rule. So I've got x and ln of x, whose derivatives are 1 and 1 over x. Using the ribbon to multiply that together, we've got 1 ln of x, so ln of x then, plus x times 1 over x, which really just becomes 1. This is what we're trying to find critical values for. So let's set that equal to 0. And if I subtract 1 and then raise e to both sides to get rid of the ln, I have x equals e to the negative 1. Now, when you're making your sign chart, something else to keep in mind is that the ln function itself is undefined for 0 and negative numbers. So f prime then does not exist for x less than or equal to 0. So our sign chart is going to start at 0 and go to positive infinity. So here's my f prime chart. Starting at 0, we have this critical value of e to the negative 1, which is a positive number. I'm not really sure what it is, but it's positive. And now let's do a little sign analysis. So I need something between 0 and e to the negative 1. Well, this is a little bit tricky, but let me pick e to the negative 2, right? If I have a larger exponent in the denominator, then it's a smaller number. So plugging that in here, ln of e to the negative 2 is just negative 2. Add that to 1, you end up with a negative. So that was kind of an easy one to plug in, no pun intended. And then something bigger than e to the negative 1 that's easy to plug into ln, well, how about 1? Because if this is e to the negative 1, this is really 1 over e, so that's somewhere between 0 and 1. So 1 would be larger, and the nice thing about 1 is that the ln of 1 is 0. So this would just give us a positive overall plugging that into f prime. So we see then that f prime is negative from 0 to e to the negative 1 and positive from e to the negative 1 to infinity. So basically then f is decreasing until we get to e to the negative 1 or 1 over e and increasing after we get to 1 over e. Well, that means that the minimum value for this thing must happen at x equals e to the negative 1, 1 over e. Now that's great, except that they didn't actually ask the x value. They wanted the actual minimum value. So you have to take this x value, plug it back into the original function. So we need to do f of e to the negative 1, or I guess you could think of that as 1 over e times ln of e to the negative 1. So what's this come out to? Well, ln of e to the negative 1 is just negative 1. You just get the exponent. And then you have e to the negative 1. So this is negative 1 over e if we fully simplify that, which gives us choice C. For this problem, we have g listed as a differentiable function with g less than 0 for all real numbers, and we're told that f prime of x, whatever f prime is x squared minus 4 times this g function. Based off of this, we want to know which is true. So we're asking about the relative mins and maxes of the original f function. Okay. Well, we need to solve for critical values here on f prime. So let's say f prime equals 0. Now, if so this means that either x squared minus 4 or g of x has to be 0. X squared minus 4, if that equals 0, then we have x values of plus or minus 2. Now g, they told us up here, g is less than 0. Well, if it's less than 0 for all real numbers, that means it can't be 0. It does not equal 0. It will never be 0. So only plus and minus 2 are critical values that we get for f prime. Let's graph an f prime number line now. We've got negative 2 and 2 on there. And let me do a little sign analysis to see where this thing is positive and negative. So if I plug in negative 3 to the f prime function, that's going to give us a positive for this x squared minus 4 stuff. G of x, they told us, is always negative. So positive times a negative gives us a negative. Next, let me plug in 0 between negative and positive 2. That gives us a negative for the first parentheses times this other negative is a positive. And finally, something bigger than 2, like 3. Well, we're going to get the same result as negative 3. This is 9 minus 4, which is positive, times g, which is always negative, so negative result there. So we notice a couple things. F prime is changing from negative to positive at x equals negative 2. Therefore, f has a relative min at x equals negative 2. And we also notice that f prime changes from positive to negative at x equals positive 2. Well, that means that f has a relative max at positive 2. So min at negative 2, max at positive 2, that is going to be choice B. On this problem, we're given this f function whose first derivative is f prime equals all this craziness. We want to know how many relative extrema, so that's maxes and mins, f has on the interval from negative 4 to 2. Well, we're basically asking how many times does f prime change signs. And this is a calculator question, so we're going to use the calculator to figure this out. So I'm on my calculator. I've entered this f prime in my y1 here, and I want to use negative 4 to 2 as my window. So I go to Window, I'm going from -4 to 2 for x values. And then let me do zoom 0, zoom fit. See what this thing looks like. So there's our graph of f prime. And it looks like, if we just redraw that here, well, we're definitely crossing 1, 2, 3, 4 times. Now this kind of looks like it's bouncing off the x-axis, but it's hard to really be sure. And I mean, we have a choice between 4, 5, and 6. So there's a lot of different places where we could end up for an answer. We better zoom in on this spot just to be on the safe side. So back on my calculator, let me go to zoom. And there's a few ways you could do this. I'm just going to go with ZBox. That lets me specify the window that I want to zoom in on. And let me just press enter to open my little zoom box and just expand that a little bit. I just want this one spot of the graph. And then let me press enter again and zoom in on that one spot to see if we're crossing or not. Ooh, it looks like we are crossing not once, but twice. Well, zooming in here, we see that we actually have 1, 2, 3, 4, 5, 6 crossings here. So that ends up being choice E with 6 relative extrema. Boy, glad we checked.